do you mean by 2 to the power 5? If I say here,
Yeah, I know the meaning.
this means
2 times 2 times 2 times 2
how
times
many times? 2, how many times? 5 times, right? Yes, that means this is equals to 32. Okay, now, this is the indices. Now, if I say you 2 to the power 15 into 2 to the power 10, write it in the simplified form. Do you know how to write it? Okay, look at the, see, whenever we write something to the power something, okay, so suppose it is a to the power b. This a is called the base and this b is called the power or exponent. Okay, or let me just tell it as power. Is it clear? So look at this one here. What we have, 2 to the power 15 into 2 to the power 10. The base is same. Is the base same over here? So when the base is same and there is multiplication here, the two numbers are multiplying here. So what you can write the same base and then just add up the power. 15 plus 10. So how much you'll get? 2 to the power 25, right? Yes? Like I'll show you one. Like suppose if I say you 3 to the power 2 into 3 to the power 5. What do you mean by 3 to the power 2? It means 3 is multiplying how many times? 2 times. Right? And what do you mean by 3 to the power 5? It means
3 is multiplied
5 times, right? So here. Now, overall, look at this line. In this line, how many 3's are there? How many 3's are multiplying?
7.
7. So can we write it as 3 to the power 7? Now follow this method here. When the bases are same, we can add up the powers. 2 plus 5, that is equals to 7. 3 to the power 7. So was it easy? Who will do on in such a long way, right? Maths is all making the work easier, isn't it? Okay, so this was just a brief introduction about indices. Okay, we'll go through that one later on. Okay, let's first learn about scientific notations. Like in physics and all, you have learned, no? What is the mass of electron and all?
I haven't learned.
Sorry, chemistry, mass of electron, then the distance between the sun and the earth, the light, the speed of the light and all. You haven't done, okay. Okay, fine, no problem, okay. So scientific notation is writing any large quantity, okay, like the speed of the light is very huge, right? It is 380 into 10 to the power 7 meter per second. Okay, so it's very huge. The distance between the earth and the sun is too huge, right? It's such a big number. So big numbers, we write it in small notation. Okay, the one which will be very convenient to use. Or very small numbers like the cell. Can you see the cell with your eyes? Cell of human body with your naked eyes. We cannot see, right? We need a microscope in order to see that one. That means the size of the cell is very small. Yes. So when the size of the, okay, can you tell me what do you mean by radius?
Radius is from the middle of the circle to the.
Yeah, from the center of a circle, the distance between the center of the circle and then any point on the circle, right? This is called the radius. Now think about the cell is very small. Okay, it's too small. And now you have to find out the radius. Okay. So it will be too small, like it will be 0.000000000 somewhere 25 centimeter or millimeter like that, right? It's such a small number, and then now you are going to write it like this. How many zeros are there? 1 2 3 4 5 6 7 8 zeros. We are going to count it and write. It will be a very tedious work, right? A long work. That means like sometimes the numbers are too huge. Okay, tell me which one is the biggest number.
In what?
Hmm?
The biggest number?
Yeah.
Like overall?
Pardon?
Like overall?
Okay, natural numbers. You tell me the biggest natural number.
I don't know. Infinity.
Yes, infinity or infinite, right? Because it's huge. We don't know the largest natural number or any number. We don't know the largest real number, right? Because it's very huge. If I'll say that the largest number is 9999999, then somebody can say plus one. which is more than this one, that also exists, right? So like this only, huge numbers are also there. Okay, now in science what happens is like we deal with the distance of the earth and the moon, okay, the radius of the earth, the diameter of the earth, all these things are very huge number. So we write it down in this what simple notation. What is the simple notation? We write some n into 10 to the power some value. Okay, so this n is called the coefficient. Okay, and that coefficient, this coefficient should be lying in between 1 and 10. Okay, not 10, it should be less than 10. Are you getting it? In between 1 and 10. And then here the value of a, this a is an integer. What it is?
Integer.
So can you tell me what do you mean by integer?
Any number.
Any number?
Any.
Give me example. No problem.
Wait.
Integers means?
Whole number. Any whole number.
Yeah, whole number. Can I say it as -3, -2, -1, 0, 1, 2, 3, and so on? All the negative numbers, 0, and then see, all the negative doesn't mean the decimal numbers, okay? -1, -2, -3, -4, and so on are called the integers, as well as 0, 1, 2, 3, 4, 5, and so on are the integers. Okay. Okay. Okay, tell me one thing, okay? 2.35 into 10 will give you how much?
23.5.
23.5, very good. If the same thing, if I multiply it by 10 to the power 2, how much it will be?
235. 235.
Yeah, 235. Okay, what about 2.35 into 10 to the power 3?
2350.
2350. Now, this one you know it from this side to this side. Now we are going to do from here, we are going to get a notation like this. Look at these notations. Do you have a number? Look at this one, 2.35. Is this a number in between 1 and 10? Yes, and then 10 to the power something. Here 10 to the power 1, here 10 to the power 2, here 10 to the power 3. So this is only called the scientific notation. Okay, now I'm giving you one number like 2, 3, 4, 5. Okay, so this you have to write it in the scientific notation. In scientific notation, there should be one number, non-zero number in the left. Like here, see, what is the number before decimal? What should be there? A number in the left. Okay, so how can you write this one? Tell me.
2.345 times 10 to the power
4 into 10 to the power
4.
4. So this is only the scientific notation. Okay, now if I suppose if I give you here 0.00023, you have to write it in the scientific notation. That means this decimal you have to bring. Okay, now for this one, initial one, okay, the decimal was not there. So we have to consider the decimal is here, right? Yes?
I can't.
We shift.
Yeah.
Yeah. So it will be shifted how many times? 1 step, 2 step, 3 step. We have shifted. So here it will be 10 to the power 3, not 4, right? Now similarly here when we have 0.00023 and you have to write it as this one scientific notation, that means the decimal you have to shift it. Where you have to shift? Towards which side? This one was shifting on the left side, this one will shift on the right side. So it will be 1, 2, 3, 4 steps to the right, right? So that means how we can write it as 2.3 into 10 to the power
-4.
Yes, minus of how many steps we moved here? 1, 2, 3, 4 steps we have moved. So it will be to the power -4. Okay. So when you are shifting to the left, decimal, when it is shifted to the left, decimal point, when you are shifting to the left, That time what you will do? 10 to the power positive. Okay. And that decimal point, if you are shifting it to the right, then what you are going to do? 10 to the power negative number. Okay. 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 Now, so this is only the scientific notation. Okay. So can we do some like basic values? Okay. Like population of the world is 7 billion, written as 7 with how many zeros? Like this. If you have to write it down in the scientific notation, can you tell me how will you write this first one?
7 times 10 to the power of 9.
It will be 7 times 10 to the power. How many zeros are there?
9.
9 zeros, right? Yes? Okay, what about the second one? It is 1080000000 kilometer per hour. How can you write this one?
1.08 times 10 to the
8
power
times 10 to the power?
7.
Okay, here. This is the decimal point. 1, 2, 3, 4, 5, 6, 7, 8, 9. Here you are writing the decimal point, right? So it will be 10 to the power 9. Okay. Here?
2.4 to the power of 5.
2.4 into 10 to the power 5. Good. What about this one?
9.3 to the power of 7.
7. Good. So I hope you can do all these things, right? Now can we do number 9? Okay, let's just look at number 9 here. So it is in a decimal one. So how will you write it in the scientific notation?
1.332 times 10 to the power of
You're shifting this decimal point here.
-3.
1, 2, 3. To the
Negative,
power?
-3.
Yes, negative or 3. Okay, what about this one? 0.0024.
2.4 times 10 to the power of 3.
2.4 into 10 to the power
3.
minus 3. Right. Okay, what about this?
7.53 times 10 to the power of.
Shall I count it for you?
No, I got it. 11.
11. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
10.
To the power negative of 10. So look at this number like mass of electron. Okay, it is like this. So many zeros, after that 9109. So whenever they will use this one, suppose they are finding out the mass of one full molecule. Okay, in one molecule of an atom, one atom, suppose. Only mass of one electron is given like this. So if one atom, in one atom of of any element, how many electrons are there? It depends, right? Hydrogen has 1, helium has 2, like that. So suppose if you have to find out the mass, then you have to multiply it by certain number. Suppose the element contains 5 electrons. So you have to multiply by this. So will the multiplication become easy when you multiply with so many zeros? Writing will be easy. There can be some mistakes also, right? Whenever you're writing this one, there can be some mistakes like you might miss out some zero. So the easier way will be how to do that in easy way. How can you do this? First, you can write it down in
9.10938822.
10938822 into 10 to the power. Sure.
32.
So it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means 30, 31, right? Check once. It's okay, I can understand because you're looking at the screen and doing, no, it will be very difficult without the pen, right? So it will be minus 31 kg. And then I said you have to find out for one atom which is consisting of how many electrons? 5 electrons. Now the multiplication will be easy, right? Tell me how will you multiply this now? You'll be multiplying this number with this 5. So how much you'll get? 5 to the 10, 11, here 41, 4, 50, 15, then 19, 1, 45, 46, and then 5, and then 45, right? Into 10 to the power minus 31 kg. Yes?
5.5.
So since already we are doing some sums regarding science, regarding electrons, it will be better if we write this one also in the scientific notation, no? So tell me how we can write this one in the scientific notation.
Just like you have it written.
Pardon?
Just like you have it written right now, 45.54691.
Now you convert this one into proper scientific notation. In scientific notation, there should be one number. This number should be in between 1 and 10, right? This number should be in between 1 and 10, but 45 is here, right? 45 point something.
4.5546911 times 10 to the power negative 32.
4691910 and then 10 to the power
Negative 31.
negative 31. What about this? You shifted this decimal to the left, no? There will be one more into 10, right? Into 10 and then into 10 to the power minus 31. Keep this minus 31 as it is. Only for this one, can we write like this? Yes, Anisha?
Yeah.
Are you getting me?
Yeah.
Are you confused?
Yeah, I'm confused how you added the extra 10.
Okay. I'm writing it over here. Okay. It is 45.5469110 into 10 to the power minus 31 kg is there, right? I asked you to write this one in the scientific notation. In scientific notation, this number should be in between 1 and 10, right? Then you said me, we can write it as 4.554691110 into 10 to the power minus 31. But are they equal? Tell me, these two numbers are equal? No. So there is actually one thing, this into 10 to the power minus 31, you keep it like this only here. Okay.
Why couldn't you do negative 32?
It will not be negative. That's what I want to say you. When you shift the decimal to the left, what did I say you? When you shift it to the left, it will be 10 to the power positive. We shifted this decimal one step here, so it will be into 10 to the power plus 1, positive 1. So overall, it will become like this, no? This thing here, look at this one. This one is now this into this, right? And this 10 to the power minus 31, we are writing it over here. Here, clear? Now then you combine it, can we write it as 4.554691110 into 10 to the power 1 into 10 to the power minus 31. Now you use indices. Just now I said you, when we have the same base and if they are multiplying, the powers will get added. So it will be 1 plus minus 31. What will be 1 plus minus 31?
Negative 30.
Minus 30, right? So it will be into 10 to the power minus 30 kg. Done?
No, wouldn't it be 1? Okay, yeah.
Is it clear?
Yeah.
Okay, good.